Okay, so the next is we are going to learn how to program this this simple board. And then I said we use what is known as the Arduino IDE to program this board, right? As simple as that. Now we know that, and then I have already emphasized that everybody knows what this board is, the Arduino Uno. Am I right? Everybody knows it. Like everybody have seen it before. Even if you have never used it before, but you have seen it before, right? The Arduino Uno, right? But all the Arduinos have the same architecture. You must know that the internal architecture of the Arduino boards are all the same. They have a CPU, right? They have memory, they have IOs. But the most important thing is that the Arduinos are it's just to control things, right? The Arduino boards are just to control things. They can't do a lot, right? It's just to control a specific thing, right? And then they actually combine sensors and actuators. So you pick a sensor value, based on the sensor value, you do something to the actuator. You guys know that, right? For instance, if I want, for instance, I can have the Arduino board, I can have my a temperature sensor, right? If the temperature of the room goes above some level, it should it should give a sound, or it should turn on the buzzer and stuff like that. A very very simple thing. This is an example of an embedded system on an Arduino board. Pardon? The what? The what? BDT. Stability and stuff like that. So there are so many sensors you can integrate with the Arduino board. We know that already. There are different Arduino boards, the Uno, Nano, and stuff like that. Then we know about the Arduino IDE, right? Now, the most important thing I said was that we have the CPU memory. Then within memory, we have different types of memory. I hope you guys know that already. We have the flash, the SRAM, EEPROM. We know what each of these does, right? What is the use of the flash? Uh, what is the use of the SRAM? What is the use of EEPROM? What is the difference between EEPROM and SRAM? Okay, fine. Then we have peripherals. What is attached to the CPU? So the most important thing is that the CPU does what? It controls all the other components attached to it, right? So normally you have an architecture like you always have for a digital system, right? There will be a bus. You guys know that, right? So we have a bus. So those of you who be studying computer engineering further, you know this architecture. There's always a bus, right? And then you have your CPU connected to the bus. You have your peripherals connected to the bus. You have your memory connected to the bus, right? This is just a bus, right? And then what the bus does is that it gives the connections to all of these components. But it also means that only one component can use the bus at a time. You guys know that already, right? So there must be some kind of control on who uses the bus, right? Perhaps I want to read something from memory, okay? Right? Data from memory and send it to a peripheral. How is it controlled? The CPU has to come in and say that, oh, read. Uh, the CPU will come in and give control of the bus to the memory to send it out to another peripheral. So that's how it works. I mean, simple stuff like that, but very complex internally, right? And then to design. But you guys, you don't have to worry about that. Unless you're going to study further, then you must really worry about that, right? So we have peripherals like the ADC. You guys know that already. Timers, UART, SPI, DMA, GPIO, and stuff like that. I hope you guys know what all of this mean as computer engineers and electrical engineers. What is an ADC? You know that already. What is that? Commenter, right? Easy stuff like this. So all the Arduino architecture look like this. Are we there? And then we can interface a lot of sensors with the Arduino boards. Temperature sensor, what pressure, switches, LED displays and stuff like that. All of these sensors can be integrated with the Arduino board. And then I think the last time I said that the Arduino consists of libraries. We only use libraries. So that is what makes the Arduino very easy to actually learn, right? There are libraries for everything. Just know how to use the libraries and then you are fine. You don't have to write code from the scratch, right? Nobody does that anymore, actually. So there are libraries available for you to use and stuff like that, right? Now, you have to know, I think the last time also, I don't know whether it was you guys or some guys I met somewhere. Yeah. I was telling you guys that for you to be a good engineer, right, you should know your, if they give you a project, or you should know the specific board to use. Not all boards can be used for everything, right? So which board are you going to use for a specific project? That is on you, right, as an engineer. So if you go anywhere with a degree, probably nobody will be supervising you. They just get a project, they just give you the project with a budget and say that you design it. So you have to know the specific board. If not, if you go and buy one board and then you see that, oh, that board doesn't have this component, it means that you have to buy another board again, and you are actually losing the, you are actually losing the place that you make money, right? And you'll be stuck within some 2 weeks or 3 weeks, right? So as an engineer, you should know the specific board to use for which project, right? And I think I give an example of if I want to design. What example did I give? Can anybody remember? I give some specific example. That does what? Okay, okay. 5 marks, 5 marks. I think he remembers specifically what I gave. Right? I said I wanted a smart camera or something like that, right? It takes snapshots. And then if the person is not around, and then probably it detects, so the camera is in, probably let's say within this hallway, right? If it detects a person within the room, it takes a snapshot and send it to via email or something like that to the person's phone and stuff like that. So how are you going to design a system like this? Are you going to use the Arduino Uno, or you're going to use the Arduino Nano, or what type of Arduino is fit for this kind of application, right? But the most important thing is that there are significant difference between the Arduino Uno and then the Arduino Nano. The first thing is the frequency, the clock frequency. As you can see that the Arduino Nano is what? 64 megahertz. And then the Arduino Uno is what? 60 megahertz. What does that mean? What does what does that mean? Frequency. What does that even mean? I mean, you guys have heard of these terms, frequency, frequency, frequency. What does it mean? Hmm? Pardon? Wait. You guys are sitting in the fun and then you guys are so pumped up, right? Look at how you look at how I'm just sweating. Standing there and you guys are just enjoying yourself. What does it mean? Frequency and what? Yes, of course, right? So if and then as a computer engineer, right? Once you go once you are studying further, right? You must the definition of frequency from you must know the definition of frequency to mean that, right? You know that as computer engineers, you are dealing with the hardware itself, right? The gates. So we go down to the gate level, to the AND gate, OR gate. That's what you are designing. And then that's what you are combining to form the complex system. So your mind, you must be thinking about the gates, right? In terms of frequency, right? Once you design a gate, once you design a complex system, right? And then that complex system has so many gates. But each complex system has inputs. And each complex system has a what? An output, right? With interconnections, right? From the inputs to the outputs, right? Yes. Whatever. So now, how we calculate frequency in computer engineering or within a digital system is that we look. So you look at this diagram here. We have this here, right? from input to output, right? So we are going to take what is known as the propagation delay from here to the output, from here to the output, from here to the output. So what is the amount of time it takes the signal to travel from here to the output? The input from this to the output, and then the input from this to the output. Then it takes the highest number, right? So that is how we calculate frequency in a digital system. The highest number, right? So what that means is that it looks for the longest path from the input to the output. Understood? So it means that the time is fixed, and then the frequency, as the guy said, is equal to 1 over time. So that simply means that if the time is long, what happens to the frequency? If the time is so long, what happens to the frequency? Common sense, that is yeah. So the frequency will be smaller. Common sense, right? So it means that if you design your digital system and then the delay path is so long, it means that you are not a very good designer, right? Because it takes so much time for the signal to get from the input to the output, right? So the frequency will be smaller. Now, if the time is so short, what happens? It's higher. Now, is that always good or bad? From what? It depends on what?
Depending on what you are actually doing.
I mean, that's fine. So that's the most important thing. So Arduino Nano has a frequency of 64 megahertz, while the other one, the Uno, has 60. So if you're designing an application like you want to take images, like take your sensor is an image sensor, a CMOS image sensor. You want to take it and then let the Arduino do something with it. Then you must use the Arduino Nano, right? Because that one has a higher frequency. Or if you are sampling audio, right, like live audio, right, then the Arduino Nano will be your best choice than the Uno, right? Then we have the flash. The Arduino Uno has 32 kilobytes flash, while the Arduino Nano has 1 megabyte flash, right? So it means that your program, the program you write, right, is stored in the flash. So if you write very, very complex program that goes above 1 megabyte, it means that none of these boards are actually for you, right? And then and then that also means that you know that for most machine learning algorithms, right, they take a lot of memory, right? So if you want to do tiny machine learning like what this guy is doing, but I don't know whether he has started or not. You have started. If you want to do tiny machine learning, right? Place the board for you. I don't know because the flash is big enough to contain tiny machine learning algorithms, right? The Uno cannot support it. It's too small. Understood? Now we also have input voltage and I/O voltage. So the input voltage is there. We have I/O voltage. Now the most important thing is that the I/O voltage for the Nano is 3.3 volts. That is fixed. Once you supply the inner circuits of the Arduino Nano with more than 3.3 volts, it will blow up. Understood? But that of Arduino Uno is 5 volts, and then we have the input voltage. So who can tell me the difference between input voltage and I/O voltage? Let's try here. Let's try here. There's nobody here. There's no one here. Okay. Master, come for it. Come for it. Higher, higher, higher. This guy is here. Okay, so let's go. What is the difference between input voltage and I/O voltage? Combine your heads. You see, at least they learn something at electrical engineering, but you guys here, computer engineers. So Oh, okay. So what happens is that for this board, right? You supply it with a voltage, right? That voltage is supplied through this USB board. Have you seen through this USB port? Have you seen it? Have you seen it? So that voltage can range from for this particular board, it can range from 4.5 to 381 volts. That is the voltage supplied through the USB board. Now, once the voltage gets into the board, we know that we have different types of components within this board, right? Those boards can only take 3.3 volts. That's one. And then we also have the pins. Now, these are the pins of the Arduino board. Have you seen them? So we have analog pins, we have digital pins, right? So now those analog and digital pins are the IO pins, input output pins, right? Those input output pins can only take 3.3 volts. Understood? You can actually supply only 3.3 volts to it. If you supply more than that, you will have an issue. So we are all there. Are we all there? So now the Arduino Uno does not have Bluetooth, but the Arduino Nano has. Right? Once you want to connect Bluetooth, you need a shield. If you want to use the Uno, you want to buy a shield and buy the Bluetooth component and then connect it. But with this one, there's already Bluetooth integrated, right? And then this one also has, it's called the Arduino Nano BLE Sense because it has several sensors on it, right? The other one, the Arduino Uno has no sensor on it. So if you want to interface any sensor, temperature, humidity, all of that, you must buy them and interface with the Uno. Understood? And then probably with all of this, which one will be more expensive? Of course, right? But for an application, right, you might end up spending more if you use the if you use the nano, right? You must end for like if you want to interface a lot of sensors, right? You must buy them independently, then buy the shield and stuff like that. That will end up being more costly than you using the Uno that has all the sensors connected to it, right? Are you all on the same page? So the next thing is okay, this is just the Arduino Uno, the Arduino Nano, and then as I said, it has sensors, it has digital pins. These pins, some are digital pins, some are analog pins. I hope you guys know what digital pins are, and then you guys know what analog pins are, right? Do you all understand what digital pins are and analog pins? How? So this is known as the pinout diagram. So, and then as an engineer, you should be able to read a pinout diagram and know what each of the components is or each of the pins does, and then whether a pin is an analog pin, and then what it even means. And if a pin is a digital pin, you want to know what it means. Right? So here, once you see this color, it means that it's an analog pin. Have you seen it? So we have analog pins from A0 to what? A7. Those are analog pins. And then once you see the deep red here, those are digital pins. So we have D12 to D2 and stuff like that. Understood? So the most important thing is that in your code, right, in running and in writing an Arduino sketch, right, once you are referring to a digital pin, you can refer to it by the number. Okay, I can say D12 or just 12, right? And then the board will know that it is the digital pin, right? I can use D12, very important, or 12. But if I want to use the analog pin, I must always use the A, then the pin number, right? Like A2. If I just use 2, it will assume that it is a digital pin. Understood? Yes. Very important. So this can be some objective question or something like that. Right? So, and then each sensor also connects to the CPU. Right? So we have the pinouts for each sensor on this board. If you go and study, you can go and study it on your own. Now, the most important thing again is that the Arduino Nano boards are so many. So you must be very careful. So based on the application you are doing again, you must know which one to use. So you see that they are almost the same, right? In weight, in structure, and in everything, but they contain completely different things, right? For instance, if you take the last two, so we have one known as the Arduino Nano BLE, and then we have another one known as the last one, known as the Arduino Nano 33 BLE Sense. You must know exactly what you use. So you must know the difference between the Arduino Nano BLE and then the Arduino Nano BLE Sense, right? So from the table, what is the main difference? But then the sensors. So now, if you are giving, you might think that the Arduino Nano BLE Sense has sensors, but they don't have sensors. That's the only difference. Understood? So you must know exactly which application you are doing and then which board to use. If, if not, you will be deceived to buy a lot of boards and stuff like that. Right? This is known as the power tree of the Arduino. As I already explained, you connect your voltage source to the through USB, right? And then that one is divided between all the components on the board. It's as simple as that. Right, so now the most important thing here too is that the Arduino has a CPU, and then the CPU is known as the RF52840. You guys have heard about it before. But I think you guys have done microprocessors 1 and 2 or something like that. Something like that, right? Have you guys done it? So you're on the same page, right? Okay, so this from ARM. You guys know what ARM is? The company, right? With what? So specifics. You must know the flash of the nano BLE sense. It's coming in the exam. What is the flash of the stuff like that? What is the SRAM? Stuff like that. So if you don't know it, then eh? The flash of the blackboard. I mean the flash of the board, right? The flash is what? 1 megabyte. The SRAM is what? The pardon? Two what? Okay, that's fine. Now, another important thing is that you know that you program the Arduino, right? I mean, some of you will be making very simple errors and then programming the Arduino, simple errors and programming the Arduinos. It's not advisable, right? Why? Because the flash, the flash weakens anytime you program the Arduino board. You guys know that, right? It's memory. Memory degrade anytime you load something onto it. Anytime you write a memory location, it degrades. You guys know that, right? As engineers, you don't know that. So that's it. So memory degrades when you write to it, right? So now the this board, right? This Arduino Nano Blade cells, you can write to it about is it 10,000 times. Then it will start to misbehave because the memory has degraded, right? So it means that you can actually program it only 10,000 times. So you have to be careful when you are writing programs, right? So if I say I program it per day, if I program it 100 times a day, how long will it take for the flash to degrade? Huh? 10 days. Your maths found to your engineering is poor and your maths is poor. So elaborate your English. Okay, are we all there? Very important. It degrades. So once you are loading, you must know that once you load it, the memory will degrade. So don't load it a lot of times. Just make sure that your code is correct and everything is working before you load it. If not, after 10,000 times, it means that your board becomes useless. This board is about 1,000 cities. And so if you load it, if you make so many mistakes and then you load it a lot, and then before your application is done, then you are in trouble. Are you all there? Any questions so far? Any question? So if I ask you a question, can you answer? So if I ask you a question, then you can answer -1. And okay, in the exams, if I'm able to set objectives, it means that it will be +1 -1. So if you don't know, you don't answer it. I don't set questions from anywhere. It's just for my head, so I suffer to set questions, right? So if case I suffer, I don't want you to guess. If I suffer to set questions, right, I don't want you to guess. If you don't know it, just leave it for me. If you know it, answer. If you don't know it, just leave it, right? If not, once we are wrong, it means that you are actually insulting me. So I'll just give you -1.
Since they asked us to write anything what if maybe you thought this was the answer, but that wasn't the answer?
So somebody, our teacher told us that you don't enter an exam hall to think. You just enter to write. So once you enter the exam hall, but it's true. Once you enter the exam hall and then you start to think, you mean that you are wrong, don't answer at all, just get up and go.
You definitely have to think before you go there.
There's nothing to think about in an exam hall. You just enter there to write. And fill up your seat and go away. Once you start to think, you are wrong already. So once I give you the objectives and then you are thinking about it, just leave it, yes, and go to the next question. Right? That's all. Once you see number 1, just circle, and then you are done. Are we all on the same page? Any questions so far? So now we are done with the hardware. So you guys know everything about about this board. About this tiny board. Very, 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 very powerful. Very tiny but very, very powerful, right? You guys know everything about it. You guys know the IO, you guys know the digital pins, the analog pins, you guys know about the CPU, the frequency, the memory, and everything, right? Right. Hmm? Okay. So now we go to the next section, which is the programming itself. And then this one, I believe you guys already know it. You guys have already learned how to program an Arduino board before. How many of you have ever programmed an Arduino board before? Oh no, somebody has done it. Oh, master. Oh, somebody has done it. Let me see your face, man. Master, you have done it before. Hey, Master, have you done it before? So none of you has ever programmed an Arduino before. Yeah, this guy's done it before, right? When? First year, first. But how many of you are doing projects that involve an Arduino board? Are you doing? You guys doing anything like that? Or yes, electrical? You're doing okay. So how many of you are doing? You are doing right. But and I've seen you somewhere before. Where? I remember. Hey, because I remember I've seen you somewhere like that. But you guys just came once and then that was all. And I believe now you guys the project is done. So only these guys are doing something with an okay, you're doing something. Then what again? Yeah, he said he's doing. Then but you guys, none of you is doing anything with Arduino board. Just raise your hand. Just raise your hand. Let me see how many. How many of you? Masa, how many of you are doing projects with Arduino boards? I'm still waiting for the hands. Oh. Ha! You guys are not doing anything with Arduino board. You guys are not doing anything with Arduino board. You guys are not doing anything. Raspberry Pi. Eh. Huh? What are you using? What hardware are you using? You are using a cutlass. What? So, but so many of you are using the Arduino, but you guys seem not to know anything about the Arduino board. I mean, by now the project should have been done by now, right? They approved it before you guys went home. I think I saw something like that. Huh? They approved your projects before you went home. I mean, for those who were approved, right? By now, you guys should be done. Okay, so now because all of you are using Arduino board, I believe all of you can program. I'm sure. You guys are just lie. I mean, students always lie, right? So I think the last time we saw the code for the blinking of the inbuilt LED, right? We saw okay, and I said that for the Arduino code is standard. It must contain the what? There are two functions within the Arduino that is constant. Without it, it won't run. The first one is what? Hey, I'm, I'm looking at you, but wow. Also, means that, but and I thought you guys were joking when you said you guys have never used an Arduino. I thought you guys were just making jokes. So you are actually going to fail this course. So, and I feel sorry for you, but failure in advance, man. All right. So the main thing is that we have two main functions, as I said the last time. There is the setup function, right? Have you seen it? Boy, setup. Have you seen it on the board? And then there is the what? The loop function. Right? So I said that anything you want to set up, right? Probably I want to control a digital pin. The inbuilt pin is pin 13 on the Arduino board. So if I want to control the digital pin, I have to actually initialize it in the setup. Have you seen it on top? Setup for a setup. So put your setup code here to run once. Right, so if I have digital pin and I want to actually initialize it, I put it in the setup because the setup function runs just once. Right? I mean, the name, the name should even say something about it. Setup. You only set up once, right? We can't set up something, you set up only once. You don't set up and set up again, right? And then we have the second function, which is the loop. Right? So the loop function runs, and then once it gets to the end of the code, it begins again. So it runs forever. Everyone there? Everyone there? So and then within the setup and then the loop, all you use is functions, just call functions. I'm going to use a temperature sensor, call the temperature sensor library and stuff like that. That's all you do. Understood? So now the next is this very, very simple code. Right? For those of you who have not run it before, so this will be probably your first code, right? And then let them just give you some 1 minute to just go through the code and see what it does, right? So just go through the code, and I'll be calling somebody to come and explain to me what it does. Let me see. Quick optimization at all. Go through it, just 1 minute. But you guys, have you learned any programming or anything like this, right? 1 minute. So program it in your mind as you guys are doing. Alright, are you done? Are you done? You are looking at me. You're not looking at the board. I said program it. Okay, so let's. Who is done? Yeah. Just tell me the output. Mm-hmm. Mm-hmm. Between what? Mm-hmm. Mm-hmm. I mean, 100%. At least,
Wow.
at least somebody will get 100% here, then the rest will get zeros. I mean, that's all it does. As he said, that's what it does, right? You guys all heard it, right? But okay, but you let's start with the for those of you who are in the Stockholm Academy. Let's start with the first line. Unsigned int counter is equal to 0. So let me ask you, what does the int day even mean? I mean, everybody has done C++, all of that. The int means what? Yeah? I can't hear you. What? Integer, right? So what is the length of an int? You know what I mean by length? You know int is a what? Data type. What is the size of int? So what do you think the size is? It's what? I mean, if I say the size of a data type, what does it mean? Probably. But pay attention here. So you guys always learn terms without even knowing what they mean. So if I say the size, once you write in your code, right, and declare something as int, something like int a, what does that mean? Uh-huh. Uh-huh. Once you declare something like int a, right? So as I said, you are not software engineers, you're computer engineers, right? You must think about hardware. Everything is about hardware. Everything is hardware, not software. So once you write something like int a, right, what it does is that in the hardware, right, it creates a space in memory to store that integer. And then that integer always has a size. The size is the amount of memory that it can store. So if you declare something as int, it means that it stores 32 bits number within the hardware, within the memory. Right? So what I said, you must think as computer engineers, not software engineers. Think about the hardware. Hardware. Once we see a good hardware, we think about hardware, not software. I mean, you know this already, right? That once you create it, it's about the hardware, it's about memory. You guys know this already. But just that the brain is just too dark. But it's fine, it's fine. I mean, you guys should have done nursing or something. I said you guys should have chosen nursing, but at least we are here. Fine, fine, fine. you didn't hear it, it's fine. I mean, whatever it is. Okay, so now wait, numbers, very, very, very important, right? Numbers. And then once we are explaining that numbers are very important, like binary numbers, the decimal numbers, unsigned number. You must know the difference between unsigned number and a signed number and stuff like that. And then you must know what it means, right? So if I give you something like this, if I say this is 4 bits, right? This is a 4-bit number. And then I write something like it has 1 0 0 0. And then I ask you, what is this number? Everybody pay attention here. So this is a 4-bit number. What is this number? You can tell me 1 0 0 0 4 bits is in. So you know that this is binary, right? It's binary, right? Now you must always know how to convert from binary to decimal. As easy as you guys learn this already. So if I say this is 1 0 0 0 what is the value in decimal? Anybody? In decimal here. Anybody? You guys have learned this already. Something like this. Yeah. What is 1 0 0 0 in decimal? Hmm? I mean, it's what? 8. Right? So in decimal, 8. But wrong. I mean, you actually look like a midwife. You shall see it decimal. Yes. Yeah. So you are very close, 8. But I didn't give you something for you to even know. Like, I didn't even give you. Huh? Is it different? Nah, this one, see 1 0 0 is binary, you know that. I want you to convert it to decimal. So, but I said just convert to decimal, right? I didn't give you a very important thing for you to even think about converting it. Right? So once you see a number like this, I need to know whether it's a signed number or it's an unsigned number. So, but if I don't tell you that, oh, convert this signed number to decimal, you can't do it because you don't know whether it's signed or not. So now let's say this is an unsigned number. You know what an unsigned means, right? What does unsigned number mean? Unsigned number means what? Only positive numbers. And then sign means what? It has both positive and negative. It has both positive and negative. So once I give something like this, and then I say it's a sign, it's unsigned, then you are right. It's 8. Now, if I say this is unsigned, it means that it's 8, right? If I say it's signed, what will be the value? Master, Nelson. So now, okay, now let's see something, right? So if I listen carefully, If I have an unsigned number, it's unsigned, so it's all positive, right? So it means that what that means is that the lowest number for an unsigned, let's take this 4 bits. What do you think is the lowest number this unsigned number can take? The lowest number. Unsigned. Yeah, unsigned number. What is the lowest unsigned number this one can take? This 4 bit can take. So once you are given a 4 bit number, you must start thinking that, and then it's binary, right? Binary can take what values? 1 and what? Just 2 values, 1 and 0. A binary number can be 1 or a 0. So if I say, oh, what is the lowest number this 4 bit can store? I must go to the individual. So this is 1 bit, 1 bit, 1 bit. So what is the lowest number this 1 bit can store? The lowest number it can store. What is the lowest number this one bit can store? Just this one bit. 1 or 0. Why are you being doubting yourself? You're being doubting yourself like 0 or 1. 0. What is the lowest number this one can store? What is the lowest number this one can store? What is the lowest number this one can store? 0. So it means that if I say the lowest number and unsigned number can store is 0, 0, 0, 0, which is decimal what? 0. Now, what is the highest number this 4 can store? I must start thinking, what is the highest number for this place? Or this place? 1, 1, 1, 1, 1, 1, 1. And then this is what? This is my what? We are doing on site. I mean, once you start to think about this one, it means that you're choosing the wrong course, right? And next now, you guys by now, you guys should find some white points and this green and alright, so 111 is 15. Right? So now I must start thinking. So there must be a formula, right? For the highest number you can store. Pay attention. This is coming in the exam, that's why I'm taking up to explain this. So for unsigned number, right, the formula is 2 to the power the data type. You guys have done this already. The data type minus 1. Right? So if it's 4 bits, right, it's 2 to the power 4 minus 1. It's the highest number an unsigned variable can store. Unsigned, right? So it means that for unsigned numbers, right, we are using the entire 4 bits to identify the number. Right? So it can be 0 to the highest by using the entire thing. So 0 to 1111. If it is 8 bits to 1118, that's the highest number. But we're using the entire range of the base to identify the number. Right? That is what? Unsigned. It's not signed. Now, if I take this same number, 1000, and I say this is signed, it's a signed number. So how do I identify that it's a negative number or a positive number, or it's a positive number? How do I identify it? Because for signed numbers, it consists of both negatives and what? Positive numbers. Right? So I must have a way of identifying whether a number is negative or positive based on what I'm giving. So I'm giving 1000. I say it's 4 bits. It's signed. How do I identify that it's negative or positive in the first place? So identify it, right? So which bit is it? Which bit? The what? So I'm giving 1000. I'm giving this number. I must know that it's a positive number or negative number. How would I know that this is a positive number or negative number? Oh, hurry up. Uh-huh. So so very important in dicta systems like or dicta logic or whatever. The first value is very, very important. Right? It is known as the MSB. Most significant bit. And then the least one, the last one is known as the LSB. Least significant bit. So we use for signed numbers, we use the MSB to identify whether it's negative or positive. So it means that once I'm doing the calculations, the first number is out. I can't use that to identify to tell if the number is 1 or 0 or whatever. Right? It's out. So I use this one to identify. So what is this value? 0. Because plus 0 and minus 0 is 0. So I use this one to identify the number. Right. So now, what is the highest positive number this 4 bit can store for sign? So I've seen the highest on sign is 15. What is the highest this positive number can store? Ah? 8. No. So how do I even begin to calculate it? So listen again carefully. Right? I say that this is a 4-bit number. We use the MSB, the last one, to identify the number. So that one is out. So once I see 1, everybody knows that the number is negative. If I see a 0 here, you know that the number is what? Positive. So that last bit is out. I think it's out. Now I'm left with only these three bits. So what is the highest number there? 1, 1, 1. So if I take out this one to identify whether it's MSB or LSB, the highest positive number is 7. 1, 1, 1 is what? 7. Understood? So that's the highest positive number you can score. So there must be a formula 2 for that, right? Right? Who can give me the formula? You guys have done this already. I know you guys have done this already. Who can give me the formula? For just 5 months, who can give me the formula? Uh-huh. Pardon? The formula. Like how I gave this formula, right? I said 2 to the power the data type minus 1. Who give me the formula? Yeah? 2 to the power the data type minus 1, then minus 1. Because so if I take this as an example, right? It will be 2 to the power what? 4 minus 1 minus 1. Don't make a mistake because this will become a but it is very, very tricky. So 2 to the power 4 minus 1 minus 1. So 2 to the power 3 minus 1 is what? 2 to the power 3 is 8 minus 1 is 7. Alright, so we get it right. So it's as simple as that. So those are just numbers. And I took time to explain this. It's not in the slide, but in the exam it will come. So you guys might know that. And then this code is just a very easy code. So we have the setup and then we have the loop. In the setup, right, the first line in the setup is serial dot. As I said, for the Arduino, we are dealing with libraries. So if we see serial dot something, right, the first one, the serial is the library, the dot something is a function within the library. Right, so I'm calling a function within a library. So the serial is a library, dot begin is a function within the library. And then I'm giving it nice. Who knows what that means? Eh? The first line in the setup. Serial dot begin nice. What does that mean? The first line, line 4. Serial dot begin 9600. This line 4. You have thought of something, but I know some junk something talked about. You're right. Just come down to the engineering, but what? Without being answers. So what does that mean? You said this right. So we are communicating, right? It means that the serial communication involves, you know that we use the USB cable to connect the Arduino board and then our PC, right? And then here we are printing something, we are printing stuff. So it means that there is a kind of communication between the Arduino board and then the PC, right? So we use serial communication. Probably you will learn more about that very soon. But a serial communication, right? Now, within the serial communication, we must establish a kind of rules. We don't just start to communicate, right? I mean, to talk to your friend or whatever, right? You must establish a kind of communication protocols. How do we communicate, right? And then with digital system, the main thing is the bit rate. How many bits can I send you? How many bits can you accept? Very important. Without setting this up, you cannot communicate between two devices, right? So the 9600 is just how many bits the board and then the I don't know the board and then the PC can exchange in 1 second. 900 per second. So 900 bits per second. That of data can be exchanged between the Arduino board and the PC per second. Simple as that, right? So that's why I said serial communication. Then the rate, actually the rate is 900, but they didn't even understand what he meant. You see, just English. Always know what it means, right? Okay, fine. So then, as I said, our next line is what? Pin mode 30 output. What does that mean? That's common sense. So, and then again, you see that. Yeah. So you must know that this language is this is just software, right? Softwares are high-level languages. They are closer to human language than anything. So as computer engineers, your programming language, I said that the last time is VHDL or HDL. You guys know that already, right? Once because you are controlling the hardware, you are not controlling software. This is just software, more software. So it's closer to human language. But if you're controlling the hardware, because it's the hardware, and then you must talk to the hardware, your language is closer to the hardware than to the human language. So we have two languages, VHDL and then Verilog. So these are the languages for computer engineers. And then that's what you use to manipulate or you use to form the logic gates. Right? VHDL and Verilog. Verilog, Verilog. You guys have never heard of it before. No. 4 years computer engineering. Yes. Nice. But so as I said, for software, it's just like it's closer to human language. So you can even look at the names and know what it's about without even knowing what it's about, right? So the pin mode means what? The pin mode 13 output means what? So the pin mode again is a library. It takes two variables, the pin, and then whether it's an input or output, right? So here, all we are doing is that we are setting pin 18 as output because we want to control pin 18 or the inbuilt LED is attached to pin 18. So we want to control it. So all we do is set pin 18 as output, pin mode 18 output. Easy. So, what did I say? I said 30. You all right, so our next, okay, so I didn't say a very important thing about the pins. We have analog pins, as I said, and digital pins, right? And then I said that analog pins. Analog pins serve as what? Inputs. You guys know that, right? You know analog pins, analog. So it's taking signals from the environment and feeding it to the MCU. So those analog pins take what? Serve as inputs. While the digital pin serves as what? Output. So it means that you cannot connect a sensor to the digital pin because the digital pin is supposed to feed or is supposed to give out a value, right? So I can connect an LED to the digital pin, right? So that I control the LED. Yeah. Move forward. What do you mean by that? So yeah, so for this, pay attention here. For this code, we are controlling a digital pin, which is pin 13. You know, as I said, a very important thing. I said that if I write the pin with just the number, it means digital pin. If I write with A and analog pin, so here we are controlling the digital pin. And then we are giving it a value either zero, we are giving it voltage, right? High or low. That's all. So we are controlling it, so it's a digital pin.
I don't think you got my question.
Hmm?
I don't think you got my question. I was
Okay.
trying to ask that is there any case in which the digital can play both of the inputs and the outputs? Or it's so because I know the analog is mainly for output.
Inputs.
Sorry, it's inputs,
Yeah.
but then the digital takes care of both inputs and
And
outputs.
mainly outputs. All you do is connect some thing to it and then you feed it with values.
Yeah, so that's what I was asking. In a system like this, where you didn't indicate that it was analog, but then there's still
Where
input
didn't
and
I indicate that it's analog?
the
What does the
pins,
30 mean?
the pins
So I said that if I don't write any number before it, what does that mean?
is digital.
So common sense. Pay attention.
So it's an output device.
Okay,
It's
so
an output device.
let's continue. Let's continue. Are we all there? Okay. The, the student, I've seen students from different schools, right? And and I realized something. And I realized something. I mean, everybody's good in their own way, right? Like everybody knows what they're doing. Probably, I think last semester I supervised one student from tech and came with and one student and then about three students from here. Right? And what I realized is that everybody knows what they're doing. But the issue was the basics. Right? So probably I shouldn't say this, it's okay. I mean, so what I saw was the basics. So they can write they can write the codes, right? But when they encounter an issue, so they don't know how to fix it, like from here. But for the other guys, they know how to exactly know exactly the basics. So and then once your foundation, once you don't have the basics, right? You know you build because you have built a building with no foundation. Of course, it can stand, but if there's you guys understand. So always try to learn, always try to listen, and always try to learn the basics. That's what is important, the basics. Very important. Even if you don't, even if you can't program, but just know the structure of the language. They know the basics. Right? So like this, once you see 13, as I said, I've been emphasizing once there's no number, there's no number. I've said it like 10 times. So just know that it's like that. So now somebody will go and connect somebody will go and connect and will go and will actually say 13, but it's looking at the analog piece, right? It's looking at the analog piece and then seeing that he has connected probably the LED to the analog with 13, and then he has kept it, and then he's confused. So that's what most of you will do, right? You have built your building with no foundation. I mean, just let's build the foundation and that's all. I mean, it's that easy. It's not really any. I mean, I was insulted more than this, but I did okay. What? Oh, hey, the insult you have gone through, I be easy. But it doesn't matter because so you become better than your lecturer. So I know that within some 2 years, you guys will become better than me, bruh, like in higher positions than me, bruh. After all, where I work is just nothing. Abi, you know there, right? My Basa place. All right, so let's continue. So now the setup just does it once. It sets up the communication between the board and then the PC. Then 960 will avoid it. It sets up the pin. Right? Now our next thing is we come to digital right. So now here again. So this is the last thing. So this digital right is a library. Takes two arguments, the pin number and either high or low. As easy as that. If you ask any stupid thing,
So I was saying for a digital right, it means that it's mostly meant for just the digital units. So what if it's analog? Will it be like analog right? Or
okay, okay. So again. So now, imagine that you write analog right here. Of course, that is also a library. The analog right is a library. The analog right is a library. So that's why I said you must know your foundation, right? The analog right is also a library. So if I write the analog right, then I come and declare pin 13 there. It means that you must have you have an issue. You know how to code, but you don't know what you're going to do. Right? And then, I mean, that's what I saw light. I mean, it's fine. But so, digital rights library takes two arguments, state the pin number, and then high or low. The high means that I've applied the voltage rate. Low means 0 volts. High means how many volts? So now I'm going. I'm going to say something. Right? So 10.3 volts. As I said, the pins can only take 3.3 volts. Right? Okay, so now a very important question. So how did I blink the LED? How was the LED blinking? So now wait. This is give you right. I can connect an LED to a digital pin, right? Then I can give it a high or a low, right? So a high means the LED is on. A low means the LED is off. How do I dim the LED?
how do you
Dim. You know what dim means, right? You know what dim means?
Yeah.
How do I dim the LED? So make sure that and I want to make sure that the LED is less bright. How do I do that? How how many results did I give you guys? I think I have about 4 more to go. So I mean, electrical engineers are here, so you guys pay attention. Okay, it's a digital pin. The digital pin can only take 3 volts or 0 volts. Now it's very important. So once I say digital, two values 0, 1, true, false, yes, no, 3 volts, 3.3 volts, 0 volts, 2.3 volts, yes, no, on, off. That's what it means. It means that there is nothing between. You cannot reduce the voltage. Now, if it's an analog signal, right, I can reduce it, but this is a digital pin. So you must know the difference between the analog pin. The analog pin can give a range of values. For the digital pin can only take 1 or 0, on or 3.3 or 0 or 2 or 4. So how do I name it? How do I name the LED? Engineers.
Vary the time between the on time and off time.
I was right.
And I must take your index number. No. Yeah. So what you do is that's all as simple as that. Like this is common sense thinking, but so the digital system, the digital signal, it looks like this, right? So pay attention here. This is a digital signal. It's either one or zero. You guys have seen this several times, so I know, right? One or zero, one or zero, one or zero. So what you can do is that because the pin takes only one or zero, right? All you can do is this. You can on it for a very long time and off it for a very short time. On it for a long time, off it for a very short time. Now, so you have on it for a very long time, right? And then you off it completely. It's off. But because your eye is so slow, right? Your eye see it as it has dimmed, but it turned off completely. But because of the time it used to turn off, that short time, your eye sees it as dimmed without being without going off completely. That's what your eyes think. But you have actually turned it on, and then you have turned it off completely for a very short amount of time, and then turn it on again. That's how you, you dim an LED. Simple, right? Okay, so this code we turn the digital intensity on. Then we have another library here, delay. Have you seen it? A library. Within the library, we have a variable, 5,000. The delay takes one variable, which is in milliseconds. So any value I write here will be in milliseconds. So 5,000 milliseconds is equal to how many seconds? 5 seconds. 5 seconds. Right? Now, I turn it off for 5 seconds, then I turn the LED on low, off for another 5 seconds. Then I print the counter value. Once you see counter, comma 2 here, in the, I'm printing, serial dot print the counter value, right? The counter on top there, have you seen zero? It starts from zero, right? The two means binary, one or zero. Like I'm printing the binary of the number. Then I do another serial print. What does this mean? Uh-huh. Serial print what? What am I printing here? What am I? So I said that I print the counter value, but in binary. Then here, I do something like the serial print, then there's something here. So what am I printing? Oh, massa. Okay, I'm never telling you so small, so let me give you. Hey, so you guys don't know what I'm talking about. This first line is a serial print counter, comma 2. You are printing the counter value which starts from 0. Is 0 here, then it's in binary. So if it's 0, we print 0. Then have you seen anything that's mine? Serial dot print. Pay attention, just pay attention. Serial dot print, then what? Space. We are printing, so we print 0 or the counter value, then space. You have seen something in the comment with nothing. That's space. Something like that. And then serial dot print counter 16. We print the hexadecimal value. For if it's 0, again the hex of 0 is 0. Then we do what again? Space. Then we print the decimal value, the counter value. And then we increment it in the next round. So the next round will be 1 space 1 space 1. In case I run the code, that's how we do it. Done. Any question? Any question? So I gave on the on a class material platform or whatever. I gave a lab there, so you go through the rest of the course and answer the question and bring it to me. And I hope you guys have all seen what I posted in the class. The both is right. Are we all on the same page? Yes.